Welcome to another episode of the Common Babbler. Here we deep dive into pedagogy and especially undergraduate pedagogy and how to teach science and how to discuss science in an undergraduate classroom. Our guest today is Professor Bryan Penprase. He is a professor of astronomy and vice president for external academic relations and sponsored research at Soka University of America. It's in California. He holds a BS in physics and MS in applied physics from Stanford and PhD in astronomy and astrophysics from University of Chicago. He is a co-author with Noah Pickus of Duke University of the New Global Universities, Reinventing Higher Education for the 21st Century. That's by Princeton University Press. And the author of Models of Time and Space, and I have the book right here, the foundation of astrophysical reality from across the centuries, STEM education for 21st century, and the power of stars, how celestial observations have shaped civilization. That's Springer Nature Publishing. Bryan, welcome to this podcast.
Oh, thank you. It's great to be here, and I'm really enjoying being here at Krea. What a wonderful place.
So you were an astronomer. So what's your favorite astronomical object?
Yeah, it's hard to choose. There are so many objects in the universe, so if I'm being forced to pick a favorite, I would probably go with my Galaxy M83 that I have a special attachment to, which is also incidentally the name of a French kind of electro pop music band.
Okay.
And at one point, both of my interests converged when I was in Australia doing some astronomy research, and the band M83 was playing in town in Melbourne. And I couldn't resist getting tickets to M83 and then
Right.
showing people their my favorite galaxy picture while I was at the concert. But yeah, M83, it's sometimes called the Southern Pinwheel Galaxy.
Okay.
It's a fantastically beautiful galaxy. It is the world champion or the universe champion, I guess, for a number of supernovae. It's
Okay.
had 10 supernovae in the previous century, which is really amazing. And that means it has this really beautiful spiral structure with blue stars and red star forming region. And it's this whole kind of ecosystem of star formation, star life, and star death. And so it's almost like a little forest of stars where some trees are sprouting and other trees are dying, and they're all kind of supplementing each other with the nutrients being in the soil of the universe. That's where we come from, actually. All the elements that we're made of actually come from stars.
Mhm.
So that's kind of a beautiful sort of laboratory for studying star formation and the impacts of it on galaxies.
M83. And
Yeah,
how far is it from us?
I believe it's around 20 million light years or so. It's a typical galaxy in terms of a nearby galaxy. So
Okay.
in my field, nearby means just handfuls of millions of light years, which is in no way nearby
Right.
because light is the fastest thing in the universe. And so a beam of light, if it were to leave this room right now, could go around the world 7 times in 1 second and come back. And at that rate, incredible speed, it takes it 8 minutes to get to the sun,
Right.
takes it 4 years to get to the nearest star, and several million years to get to the nearest galaxies.
So this is my ignorance. What's the nearest galaxy to us?
Well, probably you'd have to point to the Magellanic Clouds,
Okay.
which are two little irregular galaxies orbiting the Milky Way.
Okay.
And so those things are just about 150,000 and about 100,000 light years away.
Okay.
That's close for a
Okay.
galaxy. They're so close that they're trapped in our galaxy's gravity, and
Hmm.
so are orbiting us sort of like the moon orbits the Earth.
Okay.
The nearest full-size galaxy is the Andromeda galaxy. That's about 2.2 million light years away.
Okay.
And Andromeda and our galaxy, the Milky Way, are actually moving toward each other, and they're thought to be destined to collide in some number of billions of years in the future. Not to
Okay.
worry, we have plenty of times to get ready.
Right. Right. Okay. Yeah, that's reassuring.
Yeah.
Oh, fascinating. And you also have a number of books on astronomy, and I have this one, the Models of Time and Space from Astrophysics and World Culture, the foundation of astrophysical reality from across the centuries. I think one of the proposition is that some of the aspects of the culture is shaped by astronomical events, or
Mm. Yeah. And not even that. that many cultures, we were talking yesterday actually, I was talking to some of the faculty about universals of human culture. And this particular faculty member was saying that ghosts
Yeah.
are kind of a universal across all cultures. And I was contending that astronomy is
Mm.
another universal.
Right.
So I've been really fascinated to see how every group of people larger than a couple of dozen start doing astronomy, if for no other reason than to regulate their activities in the form of a lunar calendar.
Right.
But then once you have a lunar calendar, then various rituals come about. And then you also have the challenge of reconciling a lunar and solar calendar. So they have to look at the stars to figure out what season it is, so
Right.
that then they can coordinate on various activities, not only hunting, but agriculture, which requires, of course, critical timing
Right.
to plant and harvest at the right times. And then once you have a large enough society that you're doing agriculture across a large area, you begin to develop further practices in terms of studying the stars,
Hmm.
trying to learn more about what might be considered divine intent as seen from the stars, and also celebrating the stars. As your culture begins to mature, you'll have myths, you'll have tales, you'll have ancestors, and just about every culture in the world
Hmm.
celebrates their culture and commemorates their culture in
Right.
stars and constellations and star tales and in origin tales of how the stars came about. So that was actually the subject of my first book, which was called The Power of Stars,
Okay.
which arose itself out of a course that I taught at Pomona College for about 20 years
Okay.
called Multicultural Cosmology in the earlier years, and then Archaeoastronomy and World Cosmology more recently.
Right.
And then this book comes out of a course I've been teaching at Krea University of America,
Okay.
which I've really enjoyed teaching. And in all these years, I've really found that bringing astronomy alive in the
Right.
classroom has been really rewarding and interesting and fun, I think, for students as well. And then sort of recording some of those ideas in the form of a book has also been a lot of fun, because I can oftentimes even remember particular classes when certain ideas came through. And in the first book, I had various students actually helping out in doing some of the artwork for the book.
That's interesting because I don't know if it's true in all culture that usually the heaven is always the sky, the heavenly bodies,
Mm.
and almost in all culture. I don't know. Is that does that also have something to do with the admiration for astronomy, especially the night
Mm.
sky, perhaps?
Yeah, well, the sky, dealing with the sky and the atmosphere is a first challenge of someone trying to build what we call a cosmology.
Right.
It's how the universe is structured.
Right.
And you find in a lot of ancient cultures, the challenge is how to keep the sky up,
Right.
keep it from falling.
Right.
And so, for example, in ancient Egypt, you have the sky goddess Nut sort of stretching across the sky,
Okay.
and the earth god Geb sort of lying down on the sky. And the question is, okay, what keeps them apart? And so they have a air god
Okay.
Shu that's sort of holding the
Okay.
sky up.
Uh-huh.
And that's the most obvious of
Right.
these stories, but pretty much every culture has some mechanism
Right.
for holding the sky up.
Right.
And then that in turn then also requires you to explain what all those things are up there.
Right.
And in most cultures, there's a distinction made between the changeable, sort of volatile region that we live in that has weather,
Right.
and the more unchanging region of the stars. Because once you start doing astronomy, you begin to recognize that there are patterns in the sky
Mm.
that remain fixed
Right.
permanently, and that their appearance and disappearance with seasons also recurs without fail on the same date every year for as long as anyone will be able to remember.
Right.
And in some cases where civilizations get more advanced, where they can write down what's happening in the sky, they also begin to notice notable exceptions,
Mm.
such as solar eclipses, the appearance of bright comets,
Right.
meteor showers of different sorts, and the most spectacular of all, the supernova, which
Right.
will happen. And various civilizations around the world have recorded dozens of supernovae that have happened over the last 2,000 years. And that becomes a fascinating tool for modern astrophysicists
Right.
to be able to precisely date the moment at which stars have died based on these ancient records, and then revisit those explosions with modern space telescopes to see how the star, 1,000 years after it's dead, looks.
Supernova is kind of the dying flash of a star
Yeah.
before it's dead.
Hmm.
Okay.
Yeah, stars will live for a long time,
Right.
thankfully.
Mm.
So our star, the sun, has been around for 4.5 billion years. It's about halfway through its roughly 10 billion year lifespan. And they are the most fantastically violent places you can imagine. A star is basically a thermonuclear explosion that's so large, instead of it dispersing, it's held together by the enormous titanic mass
Right.
of all of the materials that are actively exploding. And at this moment, the sun is burning something like 200 million tons of hydrogen in its core per second. And despite that fantastic rate of energy production, there's enough mass in the sun to keep it going like that
Right.
for another 5 billion years. But eventually it runs out of fuel. And so any star, the sun or larger stars, when they run out of fuel, the interior begins to accumulate waste. So it's kind of like if you're a fire, you have a fireplace and you have more and more ashes, then
Right.
the wood can no longer burn. And so as a result, the absence of the active kind of explosive force that's pushing the star out causes the entire star to collapse.
Okay.
And when that happens, the star crunches down on its interior and bounces off of it. And that's, in the small star case, like our sun, will be a nova.
Right.
And if you have a more massive star, something like 5 or 10 times as mass of the sun, you get what we call a supernova,
Okay.
which is an incredibly violent, spectacular explosion, which for a brief moment, one star emits as much energy as an entire galaxy, which is 200 billion stars.
And it's tend to accumulate helium in the process as the hydrogen is
Yeah,
getting.
that's the basic
Okay.
fusion reaction that the
Right.
sun runs on. So you bring the four hydrogens together to create one helium,
Right.
and that releases energy. That's thermonuclear fusion.
Right.
And for more massive stars, they can actually have enough pressure inside to begin to cook the helium
Okay.
into other elements like carbon, like
Okay.
oxygen. And so next time you take a breath,
Right.
you should thank a star, because all the oxygen that you're breathing was produced inside a massive star and then released to the universe
Right.
in a supernova explosion. Because
Right.
when the universe started, we know that it had no oxygen,
Right.
only hydrogen and helium.
Yeah. Fascinating. I know that you are also interested in making the instruments, and so basically, this your field, astronomy, cosmology, is possibly very dependent on observation. So,
Hmm.
so then it's very important to build the telescopes
Hmm.
or the observatories, and possibly also spectrographs.
Yeah,
And you are interested in instrumentation.
sure.
So, what's the project that you have recently worked on in terms of instrumentation?
Yeah, most recently at my university, Soka University of America, which sadly did not have an observatory when I got there. It's also like Krea, a young university. It's about
Hmm.
20 years old.
Right.
But when I got there in 2017, I had the opportunity to build an observatory.
Right.
So just like building a university,
Right.
it's a great opportunity to outfit that observatory with the latest technologies.
Okay.
And so I was able to build a really compact, really advanced, and really modern little observatory
Okay.
that can pivot around and study stars and galaxies and asteroids and things, both under human control, where
Right.
you sit there and point, but also in a robotic mode, so you can
Okay.
program it. And so this actually turned out to be incredibly handy, because with this remote and robotic control option, when COVID happened, our
Hmm.
students were dispersed to 40 or 50 countries around the world. Our campus is also uniquely global in that half of our students come from any number of different countries outside of the US. And so we are the most international of all US liberal arts colleges at
Okay.
Soka University. But during the COVID pandemic, I was able to run lab sessions with our little observatory,
Okay.
with the students observing from, Africa or India or from all the different countries, and they would
Lovely.
actually come together in my living room
Okay.
via Zoom, and then be operating the telescope from their homes all around the world.
Wow.
So that was a lot of fun, and it's been also good for research, because I can
Right.
put it onto a script where it can revisit targets every night,
Right.
and I can actually sleep,
Okay.
which is also a good thing for the astronomer.
These are optical telescopes
Yeah,
or
this is an optical telescope.
okay.
Like in an earlier stage of my life, when I ran a larger observatory at Pomona College, I had a 1 meter telescope.
Okay.
And at that point, I was also working with astronomers and scientists at Jet Propulsion Laboratory
Hmm.
and also Caltech. And we got various grants to build instruments such as infrared camera, optical polarimeter. And we were able to then build those instruments with students on our campus,
Okay.
and then install them on the telescope and run all kinds of interesting experiments with them. And then for spectrographs, when I was a graduate student, I worked on spectrographs. And as a professor, I've worked with spectrographs on telescopes all around the world. So
Okay.
one of the tough jobs of the astronomer is you have to go to places like Chile,
Right.
Hawaii, and Australia
Right.
to take your data. And so I've used the Keck telescope in Hawaii and telescopes in Chile, especially. Chile is a fantastic place to do astronomy. And that's how I got to know M83, the galaxy. So
Okay.
it's only visible from the southern part of the Earth.
Okay. Okay. So just out of curiosity, M83 is still visible in an optical telescope. You
Sure.
mean? Okay.
It's quite bright and quite beautiful.
Okay.
Yeah, if you
Okay.
Google M83, the southern pinwheel galaxy, you'll see it's
Okay.
really beautiful.
Yeah, I mean, it sounds like a very interesting project, and of course, I know that I think California always the institutions have there are quite a few centers and
Hmm.
observatories
Yeah,
around in California. Probably the
yeah,
weather really helps, possibly for
sure.
observation.
Yeah, I mean, we Californians, we're known for our beaches,
Right,
maybe Disneyland,
right.
maybe The Housewives of Orange County. I
Yeah.
heard from someone here that's a popular show,
Okay.
and I actually live in Orange County,
Okay.
and I will not confirm that that's what life is like on a daily basis out there, but it makes for good drama.
Right.
But one of the things that we Southern Californians are also quite proud of is that it's been pretty much the world center for discovery in astronomy astrophysics
Right.
for over a century,
Right.
beginning back in the beginning of the 20th century in 1908 when the Mount Wilson Observatory was the world's largest telescope,
Right.
and then continuing onwards even till today when California astronomers have built the Mount Wilson telescopes, the Palomar Observatory, the Keck telescopes in Hawaii, which are
Right.
the largest telescopes, current optical telescopes currently, and then with the Jet Propulsion Laboratory, any number of spacecraft that have been roaming across the solar system, exploring Mars and Jupiter and Saturn. So it's been an amazing place for astronomy, and it's a wonderful legacy, I think, for our state, and a fun place to also work. Yes, because the weather's quite good,
Right.
so it's easier to. That's how it got started.
Okay.
Nowadays, there are so many people in Southern California that the light pollution doesn't make it a great place
Mm.
for observations, but it is a great place for astrophysics, where you have all this talent and all these smart people that live in the same place.
So I just realized that so your master's was in California, Stanford,
Yeah.
and then I think you went to Chicago,
Hmm.
but afterwards Pomona College is also in California.
Yeah.
So you have and then now you are in best out of California, but in between you were in Singapore for some time.
True. Yeah.
Okay.
You want to hear the story?
Absolutely. Yes.
And yeah, I sort of made the usual sort of perambulations that academics do. So
Right.
going off to graduate school, there was a brief diversion to the Hubble Space Telescope Institute in Baltimore,
Okay.
where I was based for a couple of years, and
Okay.
then back to California. And I was based there in Claremont, where Pomona College is located, for about 20 years, teaching at Pomona College. And then at one point, it was actually 2007, the Singaporeans came to Claremont and they were curious about starting a new liberal arts college in Singapore.
Okay.
And it would have been entitled Singapore's new Claremont NUS College.
Okay.
And so I was involved with a lot of other faculty and the presidents of the Claremont colleges, thinking broadly about if we had the chance, how would we build a new liberal arts college?
Right.
And that was so exciting to me that I just couldn't put the idea down.
Mm-hmm.
And while the Claremont NUS College never happened, a couple of years later, Yale University got the call from
Right.
Singapore and said yes. And so they ended up building what became Yale NUS College.
Right.
And so I had the opportunity to get involved in that because one of my friends, a fellow astronomer, Charles Balin, was to be the inaugural dean of
Mm-hmm.
this new college. And so I sent him a quick email saying, hey, that sounds really amazing. Do you need any help? And he
Right.
said, sure, come on out. So within a few weeks, even, I was out in New Haven and I got involved in the early days in helping outline the curriculum
Right.
and devised some of the key parts of the science curriculum with the team out there in New Haven. And we also wrote this sort of blueprint document about the Yale NUS curriculum, which was something of a manifesto for what liberal arts should be, could be.
Okay.
And it was a really wonderful process being involved in all of that. And we were able to put some of these ideas into life in the form of this new college, which
Right.
I eventually had the chance to join as one of the early faculty members and the inaugural director of their teaching and learning center, which I did for 3 years. And so I packed up my younger daughter,
Right.
our two dogs,
Mm.
and my wife and I had something like 8 suitcases, and we jumped on an airplane and lived out there for 3 years.
Okay.
And it was quite exciting and just an amazing adventure.
The food must have been very
Oh,
interesting.
yeah,
Yeah.
absolutely. Yeah, I love the char kway teow, it's called. It's a
Okay.
fried noodle dish,
Right.
and laksa, of course.
Okay.
Yeah.
And then now, so from there, I suppose you went back to Soka University.
Yeah, so after
So-
3 years out there, I had the chance to come back to California,
right.
which has sort of a gravitational pull for me.
Right.
And I ended up having opportunity to not start a new university, but to have a new university in the process of building a new science program.
Right.
So I got hired to become the dean of faculty, and I was out there for several years leading the development of our new interdisciplinary life sciences program.
Okay.
And that was very exciting. We had a brand new building, we designed a new curriculum, we hired faculty, and after a couple of years, what was a hole in the ground became this beautiful academic building filled with faculty, and then a couple of years later, after COVID, filled with students.
Right.
And even today, when I walk through the building and I
Right.
see students in their lab coats doing experiments,
Okay.
it's just mind-boggling to think that none of this was here. It was just a hole in the ground back in 2017 when I started out there. So that's one of the exciting things about starting a new college or a
Right.
new program. You get to sort of build something from the ground up.
You are an astronomer,
Hmm.
and so let me ask you this: why liberal arts? What in liberal arts kind of interested you, and you thought that your field and the more technical field of astronomy is a perfect fit in liberal arts?
Yeah, so that's a good question. And I think in general, a person should know that life is not something you can predict. And it certainly wasn't the case in my life that I could have predicted I'd be sitting here now in India having done all this, liberal arts stuff when I was a younger person just interested in studying galaxies. But there were things that were pointing me toward liberal arts from a very early stage, because when I was at my graduate studies, I did a couple of things that I found to be more rewarding and exciting, even in some ways, than the research, which was I had a chance to do planetarium shows at the Adler Planetarium in Chicago.
Okay.
And that was just so much fun presenting the skies and
Right.
explaining galaxies to the public. And then I would give tours of our little observatory up in Wisconsin to visitors. And that little observatory is up there. In 1896, it was the largest telescope in the world. And George Ellery Hale, the same guy who built the Mount Wilson Observatory, was in charge of this little Wisconsin observatory and built the Yerkes refractor.
Okay.
Anyway, I found it so much fun communicating to people about the subject that I realized that not only was it fun, but it was also important, because in order for science, like astronomy or any field, to happen, people need to support it. People need to understand it, and people need to really appreciate the value it brings to our lives. And so I think communicators of science play a really important role.
Hmm.
And that certainly can be people like yourself who run an influential podcast,
Right.
or it could be other other presenters that are more famous that are on
Right.
television,
Sure.
or it could be people at liberal arts colleges, I think, who play a key role in interpreting, articulating, and translating their very complex research
Right.
fields into terms that undergraduates can understand, and can also then bring those new people into the field.
Right.
And to my amazement, the US liberal arts colleges, which has over a century of experience with this, leads all categories of universities in bringing undergraduates into research fields in STEM
Right.
fields, science fields. If you look at them in a per capita basis, in other words, take the number of students who come out of these liberal arts colleges and go into top PhD programs, and even include, if you like, the number of US students who get Nobel Prizes,
Right.
and a disproportionate number of them come out of these small colleges compared to larger universities
Mm.
like Yale or like University of California, which are doing a great job also.
Right.
But the fact is that the percentage of students who are able to get that personal mentoring and that really great instruction in the classroom
Right.
is higher from these kinds of schools.
Right.
And so I would say, to any parents out there, when your student is an undergraduate, that's what matters most
Mm.
is having the professors there,
Right.
having them interested in undergraduates, and having them caring about and able to teach their subjects
Right.
in ways that are engaging, compelling, and inspiring. And so I found that whole kind of culture of liberal arts to be fantastically energizing and interesting. And it also, as a faculty member, gives you the opportunity to rove across your narrow specialty
Right.
and learn from colleagues in all different fields. So my interest in what then was called multicultural cosmology allowed me to talk to, get to know, and even go on trips with students, with our anthropologists, with our
Right.
geologists, with historians of different kinds. And I learned so much from that process. And it was fantastically enriching and I think more interesting for the students as well.
And also, that is probably, I mean, you have this book also, The New Global Universities Reinventing Education in the 21st Century, where I think you have discussed many of the things that you have found in your uh, career in different universities and some of the newer projects that you are involved with. So,
Yeah.
would you say that, so among the new global universities, do you see the kind of recognition that liberal arts that you think that it should get, or
Yes.
okay,
Especially in countries that haven't enjoyed a century
right,
of the liberal arts practice.
right,
I think it's being rediscovered in some of these countries,
okay,
many of which have a very distinguished and interesting history of their own
right,
in bringing what we would call liberal arts to their students, but often in an earlier century
mm,
before kind of modern industrialization and colonialism
right,
had sort of placed kind of a more mercantile and kind of specialized
right,
approach to education. So the idea of cultivating oneself in a way that exposes a student to all different branches of knowledge, all the different ways that you can find truth
right,
from different vantage points, and then combining those vantage points together to get perspective on a problem that comes at from different angles is a very powerful way
mm,
to solve complex problems. And I think a lot of countries are recognizing that. And so the uptake and interest in liberal arts in countries like India,
mm,
across Asia,
right,
and even across Africa
right,
is increasing at a rapid pace. Not so much because it provides you a direct path from A to B, if B represents some very specialized field with technical skills,
right,
but more that it prepares you in such a complete way for the longer journey to other destinations that you may not even know about or that may not even exist at this point.
right,
And that's the power, I think, of liberal arts is it creates in a student the capacity to have this sort of cognitive agility, sometimes called, where they can switch lenses from different methodologies. And they can also, from that diversity in their studies, be able to talk across different field vocabularies and learn new fields in their lives, and then retrain themselves or work with people from
right.
different fields. And so that's the liberal arts advantage. And it's a genuine competitive advantage that liberal arts graduates enjoy, even if their employers may not recognize it at the beginning.
Right.
Over a longer term, their ability to work with others, to communicate in more articulate and creative ways, and their ability to assimilate different sort of domains of knowledge make them incredibly powerful assets for employers and also give them capacities that a more specialized and more narrowly trained person may not have.
You mentioned that you have been involved with quite a few such projects in Asia, like I think you mentioned the Habib University in
Mhm.
Pakistan,
Yeah.
Singapore, of course,
Mhm.
in China, Shenzhen,
I have some friends out at Shenzhen. Yeah.
Shenzhen, and of course in India, possibly you were also part of the initial set of people
Mhm.
who were brainstorming sometime around 2014 and 2015,
Yeah.
uh, while Ashoka University was
Mhm.
starting in Delhi and maybe Jindal,
Mhm.
Shivnadar, Symbiosis
Yeah.
possibly. So what's your experience in India now that some of the universities have been around here for 10 years or so? So did they how did they measure up? Or
Well,
rather, okay, let me put it this way. How have they matured or how have they developed?
yeah, well, I'm really happy to see that they've grown up.
Right,
And sometimes you can use the analogy with people, you know. So when I was working in Singapore, these schools were babies. They
right,
were just starting. And I was meeting with their founders at the early days, like liberal arts in India, yeah, it was just a handful, a few places. There were, of course, longer established places like Flame that had been around. And then there are, of course, liberal arts programs within larger universities. But the private nonprofit liberal arts sector was just beginning to take root. And Ashoka University was the one that I was most familiar with
right,
because when I first came to India in this capacity of kind of learning about liberal arts,
right,
I had the chance to meet with Ashish Dhawan and Pramath Sinha, so two of the founders of Ashoka University. And they were really so enthusiastic, and they had actually taken our curriculum document that we wrote up for
right,
Yale and US, and they were studying it, and they found it to be helpful for them as they began to make their plans for what became Ashoka University. And at that time, it was called the Young India Fellowship.
right,
And I had a chance to visit the Young India Fellowship. I had a chance to give a talk there on astronomy, and I was really excited by the quality of the students there and their enthusiasm
right,
for liberal arts subjects.
right,
And so I really immediately recognized that liberal arts could really take root in India because of the creativity and energy of these students, and because it's also not well represented in the educational
yeah,
ecosystem. You
right,
have your wonderful IIT system, your ICER system, you have management schools, and you have enormous public universities, which are all doing great things.
right,
But this small private liberal arts college is not really well represented, and it performs some really important functions in the US context. And I think now that the Indian universities that are growing here have taken root, it's taking a life of its own, and sort of reinterpreting liberal arts from the Indian context
mm,
with unique and exciting elements as well. So I was very excited to see this happen, and I was very happy to have a sort of a seat in the sidelines watching all this from Singapore.
right,
And over the years, having visited a number of these schools over years and watching them mature into full universities that are among the top in India, attracting some of the best students and getting a lot of great recognition. So it's wonderful to see happen.
right. I think Krea is newer even by that standard, while
Hmm.
Krea started in 2019,
Hmm.
essentially. I think in one of your article in Forbes, you mentioned about liberal arts curriculum, and I think you mentioned about Krea
Yeah,
also. And so you knew Nirmala at that time, or you came
right.
across her. Okay,
I met her a couple of times, but the most recent time was at Yale and US College
okay,
in Singapore, where they were having a conference on liberal arts. But I also met her in Boston. I was there for a year on sabbatical at
okay,
Harvard, and very excited to see to learn about Korea and to see it sort of. As an astronomer, I would say it would be another star
right.
in the constellation of liberal arts colleges.
Thank you. That's very kind.
A new star, yeah.
And so now that you have been here for a few days and you've had a chance to interact with students,
Hmm.
so I think the biggest sort of a blind spot is for us, I think,
Mm.
as faculty, is what the students are thinking because we
Mm.
are too close and sometimes maybe we don't know what the students are thinking, but maybe as an outsider, you got a chance to interact with students and have a conversation which is slightly more. It's the inhibition level is lower, possibly. So
Yeah. Well, I actually have mostly been talking to faculty. This has been a short trip, but
right,
when I come back,
right,
I'd love to meet more with students, maybe even doing some astronomy things with
okay,
them.
lovely,
But the few students I have talked to, they were incredibly enthusiastic about their studies. They had lots of questions for me about astronomy. Um, they just had a vitality and energy to them that was quite
right,
and engaging and fun to see. So yeah, and like liberal arts students everywhere, they have a curiosity and an energy that is, I think, unique and not bound by or contained by narrow specialty
right,
focus,
right,
which is great because the universe does not operate knowing that, say, a frog or a star or a tree are in one discipline,
Right.
even though you might think of them as being belonging to a discipline.
Right.
All the various disciplines come together
Right.
in order to make those things.
Right.
And so being able to study
Right.
as a student, bringing all the different sciences together, as you say here, interweaving them,
Right.
I think is a powerful way to see things in all of their richness and depth.
What I know, we probably do not get as many clear days as probably California
Mm,
at night, and also although the place is relatively desolate,
mm,
there is still light pollution
mm.
because of the other buildings around here. But do you think that this will be conducive of making an observatory here?
Yes,
Okay.
in a word.
Okay. Okay. I love that.
Certainly compared to Singapore,
Okay.
where you're lucky if you can see maybe 2 or 3 stars,
Okay.
and but probably compared to almost any other of the urban locations in
Right.
India, you're out far enough
Right.
that the skies are actually quite good compared even to Los Angeles, where I live.
Right.
Thanks to your hospitality, we had a nice evening watching the sunset
Right.
on the rooftop terrace,
Yeah.
and the stars were nice and clear.
Right.
One of my tests is if you can see the Pleiades clearly,
Okay.
which is a little star cluster next to Orion,
Okay.
and it was showing pretty well.
Okay.
You're right, there is light pollution from these neighboring places.
Right.
So if you were to build an observatory, you'd probably want a small one on campus just so
Mm.
students can get to it,
Right.
and then maybe another one of these remotely operated things just a few miles away. And with all the technology experts here in India, I'm sure it wouldn't be hard to rig up a little wireless, or even a phone link to
Mm.
the observatory to be able to gather data from a darker place just a few miles down the road.
Oh, that's a great idea.
Mhm.
Okay. Okay. Thanks, Brian, and it was wonderful having you here with us today, and thanks
Sure.
for your time.
Thanks. It's been really fun.
I'm glad you came over here,
Same.
and fortunately the weather has been nice. Otherwise,
Ah,
this place gets hot, and especially in
ah,
later part of the year.
yeah, I'm
Uh,
sure. Well, no, it's been beautiful, and it's wonderful to see all the flowers on the campus and everything blooming, and just a lovely campus. And I think your location out here is just amazing. You have all the mountains and
right,
clear skies, which as
right.
an astronomer I appreciate. So it's a great chance to see this really beautiful campus, and I'm happy to be here.
Thank you, and thanks for watching. And this is the end of this episode, and we'll be back with a new episode of the Common Babbler soon. Thanks again.